Hello. Today we are starting with the next chapter, chapter number 4 of paper 1, Operational Amplifiers of 12th Standard Applied Electronics. Now, the topic which we shall talk about right now is just the introduction of that chapter. So, let us start with it. Now, this is the chapter on page number 61 of my notes, or you can use any type of book also, that doesn't make any difference, but right now this is the chapter. So let us go to it. This is the introduction on page number 63, and we have to see the details about it. Now, one thing we have to be very careful about this chapter, that this chapter is extremely important in 12th standard electronics HSC board examination, because much of the part is asked regarding this chapter in particular in HSC board examination. Now, the operational amplifier is a type of amplifier which does the process of amplification along with some mathematical operations, like it can do the addition, then subtraction, then it can do the integration of some input quantity, means it can find the integral of input quantity and give you proportional output. Then it can also differentiate, means get the derivative of some input quantity at the output. And there are other functions also that we shall see in this chapter. Now, before going into the details of the chapter, let us see what is an amplifier first. An amplifier is simply a device or an electronic circuit which increases the strength of electrical signal connected at its input. So let us consider that this box contains one operational amplifier, or simply an amplifier. AMP stands for amplifier. Now here I connect the input signal, and across these two input terminals, suppose I connect one microphone over here, and this microphone is suppose picking up the sound waves from outside. So as we know that microphone is a transducer which converts sound energy into proportional electrical signals. So these electrical signals generated by the microphone will go into the amplifier input terminal, and across the output it has got two output terminals, and suppose across the output I connect one speaker over here. Speaker is exactly opposite type of transducer with respect to microphone. Speaker converts electrical signals into proportional sound signals. We have studied these two transducers in the third chapter, transducers. Now what will happen, that when this input signal goes into the operational amplifier or simply an amplifier, there will be some kind of process that will take place inside this amplifier, and once this process is done, then the output will be generated, and this output will be fed to the speaker, and the speaker will produce the sound waves at its output, and the strength of these sound waves will be quite high, because this amplifier will receive a small input signal and will produce a large output signal. Now you might be wondering that how it happens, where from the amplifier is getting that much energy to produce a strong output. So for that we have to understand always that whenever we talk about amplifier, we assume that the amplifier circuit is connected to some kind of external battery, and it is assumed, it is generally not shown in amplifier circuit that there is a battery, but we have to assume that the amplifier is working actually on external battery, and that is a very important part, because amplifier cannot produce its own energy. It is not a kind of active transducer or something like that. It is simple electronic circuit, and it receives the input signal from some device like, say, this microphone or an iPod or something like that, and then it processes the input signal and then produces the strong output, and that output will be converted into sound waves with the help of speaker. So this is the general purpose setup of an amplifier. Now let us move to our chapter. Here the point is given as fundamentals of amplifier. Now the fundamentals of amplifier, there are some important points which we just discussed. Basically, the amplifier receives the input signal and gives you proportional output. But in a general sense, we have to understand one more thing regarding amplifier. That suppose this is one amplifier here again. I draw it like this. It has got two input terminals and two output terminals. This is an amplifier. It is of course working on external battery. Then there are two types of amplifiers actually in a general sense. One amplifier which is suppose receiving this kind of sine wave at the input, then the output will be having a strong output signal. Means the output will be as such. This will be the output. Now see what is the difference between these two signals over here and over here. This is the input signal and this is the output signal. But there is one very big difference. Here the input signal has the positive half cycle over here, and at that very same time we are getting negative half cycle at the output. So this type of amplifier which produces negative half cycle at the output when input is at positive half cycle, then such type of amplifier is known as inverting amplifier. Inverting stands for simply the change of polarity that takes place in such kind of amplifier. So if we apply positive half cycle at the input of the amplifier, then at the output we will get negative half. Of course, this negative half that we shall get will be having large magnitude as compared to the input signal. So this type of amplifier is called inverting amplifier. If we apply a negative half cycle at the input of amplifier, then at the output we will get a strong positive half cycle. So in both cases, if input is negative, then output is positive. If input is positive, then output will be negative. Such kind of amplifier is called inverting amplifier. Now there is another one that you must have guessed, and that amplifier is called as simply non-inverting amplifier. It has also got two input terminals like this. Then the two input terminals are as such. Amplifier, of course, connected with external battery. Now here we apply positive half at the input. Then at the output you will get a strong positive half. So when input is positive, output is also positive. Such type of amplifier is called as simply non-inverting amplifier. So there are two types of amplifiers, inverting amplifier and non-inverting amplifier. If I apply a negative half cycle at the input, then at the output I will get negative half cycle like this. So in non-inverting amplifier circuit, the output follows the polarity of input. But in inverting amplifier, the output does not follow the polarity of input signal, and it inverts, means it produces the opposite of input signal at the output. Hence, there are two types of amplifier which is said in our notes here. There are two types of amplifiers, inverting amplifier and the non-inverting amplifier. Now we have to see the concept of feedback. Now feedback is also a very important point we must understand. as you might be knowing the meaning of feedback, then it is simple to guess something regarding feedback. Suppose I take one amplifier here, and to this amplifier there are two input terminals, two output terminals, and I am applying some input signal, say Vi as the input signal, and I am getting Vo as the output signal. Means I am applying some voltage, small voltage, say Vi, and I am getting large output voltage as Vo. In that case, we have to apply the feedback in this circuit. Now, what is feedback? The definition of feedback is very simple. Feedback means connecting the fraction of output quantity back to input is known as feedback. Connecting the fraction of output quantity back to input, such connection or such connectivity is called feedback. Connecting the fraction of output back to input is called feedback. Now suppose I take one resistor here and connect that resistor between the output and the input terminals. This is one resistor. Let that resistor be labeled as RF. RF stands for feedback resistor. Now this is a feedback. Now since there are two types of amplifiers, inverting amplifier and non-inverting amplifier, and amplifier needs a feedback, naturally there are two types of feedbacks because there are two types of amplifiers. Now what these type of feedbacks are? If I take one inverting amplifier like this, now I draw just one input terminal here and one output terminal, that doesn't make any difference. Here I apply input voltage Vi and here I get output voltage Vo at the output. Here is the input. This is amplifier. Of course it is inverting amplifier, and if I connect one feedback over here like this by connecting one resistor, let that resistor value be RF, then this type of feedback is called as negative feedback. Negative feedback. Remember this point, it is very important for HSC board examination preparation. When we connect feedback in inverting amplifier, that feedback is known as negative feedback. Now if I take another amplifier here, let that amplifier be, say, non-inverting amplifier. Input is connected, we are getting output as Vo, input as Vi, and I connect another feedback over here like this. This is feedback resistor RF, this is amplifier, it is of course non-inverting amplifier. In that case, this feedback is known as positive feedback. Positive feedback is a type of feedback that we connect in non-inverting amplifier circuit. So there are two types of feedback. The feedback that we connect in inverting amplifier circuit, it is called negative feedback. The feedback that we connect in non-inverting amplifier circuit, it is called positive feedback. Now let us move to our notes again. Input output resistance of amplifier. This is one very important point. Input output resistance. Now as I told you, we take one amplifier here. Okay, this is amplifier. I connect the input. Sorry, this sometimes my iPad doesn't work properly. I will have to wipe it out. Okay. So here I connect the input and here I take the output. Okay. Now we have to see the input and output resistance here. Point number 4.2.2. So what is that? Let us see it. So if I apply, suppose, some input voltage Vi and I am getting some output voltage Vo, Naturally, when I apply this input voltage Vi, some current will flow into the amplifier. Let that current be II. II means input current. This small I indicates input. This small I indicates input. This capital I indicates current. This capital V indicates voltage. So when we apply input voltage Vi, some current will flow, that current is II. Then naturally we can apply Ohm's law here and we get Vi upon II, that is equal to Ri, because voltage upon current is equal to resistance according to Ohm's law. So our voltage is Vi, our current is II, then naturally this resistance Ri that came out is known as the input resistance of this amplifier. So every amplifier has certain input resistance. Similarly, when we are getting this output voltage VO, naturally there will be some current. That current is suppose IO. IO is the output current. O stands for output. VO is our output voltage and IO is our output current. Here also we can apply Ohm's law, and in that case we get VO upon IO, that gives you RO. RO is known as output resistance of the amplifier. So every amplifier, whatever type of amplifier it may be, it has two types of resistances. The input resistance, that is the resistance on input side of the amplifier, and the output resistance, that will be on the output side of the amplifier. And between this input side and the output side, this part of the amplifier is actually the processing part within which the process of amplification is taking place. So that is explained in the notes. Now RC and DC amplifiers. RC and DC type of amplifiers are actually different types of amplifiers. Let us see about it. RC and DC amplifier is actually a type of amplifier which uses multi-stage amplifier circuits. Means suppose I take one amplifier over here, amplifier number 1, say A1, then I connect another amplifier, say A2, then I connect another amplifier, say A3, and I connect them. First I connect the input signal over here at the first amplifier, then the output of first is connected to the input of the next. The output of A2 is connected to the input of A3, and A3 output is taken as our final output VO. So this type of connectivity is known as multi-stage amplification. In multi-stage amplification, the output can be as strong as possible. Generally, we never use a single amplifier to amplify the signal at a very, very strong quantity, because that is not the good practice. What we have to do, suppose my input voltage over here is just 1 volt and at the output I wanted 100 volt, for example, then I shall use 3 amplifiers or more than 3 amplifiers like this. If I use a single amplifier and connect one volt input at the input terminal, and I expect output voltage to be 100 volt at the output, then this type of amplifier will not work properly, because there are some technical difficulties which does not allow us to use a single amplifier to get the maximum possible output in just a single stroke, just in a single stage amplification. So it is always a good practice to use this type of amplification. In today's modern sound systems, in our mobile phone or in karaoke systems and all these modern type of musical systems, there are always multi-stage amplification circuits used, to get a very strong possible output, and with the help of multi-stage amplification we can obtain the quality of the amplification at a very good level. So multi-stage amplification is another important point. Now actually we wanted to understand what is RC and DC. So let us see that. I am coming to that point. Multi-stage amplification leads to two types of amplifier circuits. One is called RC and other is called DC. DC doesn't here stand for direct current, remember. Now let us see what is RC. Suppose I take one amplifier over here. Let that amplifier is A1. Here I take another amplifier A2. And here I take another amplifier, say A3. Now I want to connect these three amplifiers together in a multi-stage amplification process. So I connect the input signal at the first amplifier, say VI, I connect it over here, and I expect the output voltage to be over here. Now I want to connect these amplifiers together, but I do not connect them directly. I connect them through R and C, means resistors and capacitors. So I take one capacitor like this and connect in between the amplifier, two amplifiers. I take another capacitor over here and connect it like this. This is C1, this is C2, and I connect the resistors also like this, and these resistors will be connected to some battery terminal, either positive or negative or something like that, depending on actual designing system of that multi-stage amplification circuit. So here what I am doing, here I am connecting R1 and C1 combination. Here there is resistor R2 and C2. So this type of amplifier is known as RC amplifier, resistor capacitor coupled amplifier. And the second one is simple. The second one is like this. If I take again three amplifiers, A1, A2 and A3, A1, A2 and A3, and connect them directly to each other. Here I apply input voltage, here I get the output voltage. Then this type of amplifier, multi-stage amplifier circuit, is known as DC amplifier, means direct coupled amplifier circuit. The direct coupled amplifier circuit has low quality at the output. Such type of amplifier gives you strong output, but the output quality will suffer. On the other hand, if I take RC coupled amplifier like this, then I am connecting A1 to A2 through R1 C1. I am connecting A2 to A3 through R2 C2. So such type of amplifier gives you output voltage which is strong as well as high quality. Okay, so this type of amplifier, RC coupled amplifier, is known as hi-fi. It is not Wi-Fi, it is hi-fi. Hi stands for HI, high. HIGH, high. This is shorted as HI. And FI stands for fidelity. Fidelity is one very important parameter for an amplifier. Fidelity means the ability of the amplifier to reproduce the signal or to reproduce the replica of input signal at the output. Means the output voltage will be heard just like input voltage. Only the output voltage will be louder. It will be strong. But the quality at the input will be same at the output. Only the output voltage, output signal will be strong enough. Means it will be loud enough. So in that way, these are the important points which we wanted to discuss in the introduction part of our chapter number 4. Now, there is one also important point, that is drawbacks. These drawbacks are rarely asked in HSC board examination. There are certain drawbacks, of course. Every circuit has certain drawbacks. there are drawbacks of RC and DC amplifiers. In RC coupled amplifier, the capacitive reactance is high at low frequencies. As we are connecting the capacitors in between amplifier 1 and amplifier 2, then amplifier 2 and amplifier 3, there the capacitor produces certain opposition to the signal, and due to that we do not get that much strong output. For that we have to use more stages of amplification. And one very important point in RC coupled amplifier, its gain is low. Now gain is also one very important point to note. Suppose I take one amplifier here and I connect the input signal, say Vi, and I get the output voltage as VO, then the ratio of output quantity to input quantity is known as gain of the amplifier. Naturally, the output of amplifier is greater than input, so the gain will be always greater than 1. Remember always, in amplifier, the gain will be always greater than 1. So, in RC amplifier, the gain is low. So, what we have to do? We have to use number of stages to amplify the signal faithfully and produce strong output as well as quality output. So, RC coupled amplifier gives you low gain, but the quality is better. In direct coupled amplifier, it has high gain, but it picks up noise. Noise means any unwanted quantity which we do not want at all at the output. But since the noise is also available at the output in direct coupled amplifier, its quality is poor. So in RC coupled amplifier, the gain is low but quality is better. In DC amplifier, the gain is high but the quality is less. So these are all the points which we wanted to study in our first introductory part of this chapter, and from tomorrow we shall start with differential amplifier. Thank you.